So in this problem, we have to find the domain and range of the given functions, and later we have to sketch the graph of the function. We've already solved the problem for the first function in the previous lecture. Link of the video is given in the description box. Here we are solving the problem for the second function. So the functional rule for this function of two variables is f is equals to 9 minus x squared minus y squared. Let it be equals to z. Let d be the domain of this function of two variables. So domain will be collection of all ordered pair xy in this two-dimensional plane, that is xy plane, such that z equals to 9 minus x square minus y square is always well defined real number. So only those xy values in domain are allowed, which when we plug in this rule, the corresponding z value is always well defined and it's always a real number. What does it mean by well defined? It means we should not get forms like 1 over 0, okay, because this expression is not defined in mathematics. What does it mean by real number? Suppose this rule happens to be in the form of a square root, and we know that a square root of negative number is always a complex number, okay, and we need this z values a real number. So we should always take xy in such a way that if this expression is under a square root, then the expression under this square root should be always greater than equals to 0. So coming back to our problem, whatever the values we give to x variable, whether it's positive, negative or 0 number, and same is true for the y variable, this z will be always well defined and a real number. So in this case, domain will be collection of all xy in set of real numbers such that x can take any real number in interval minus infinity to infinity, and y can take any value in the interval minus infinity to infinity. In fact, in this case, the domain is entire xy plane. And the other way of understanding it is this function is a polynomial function in x and y variables. Okay. And for a polynomial function in two variables, the domain is always the entire two-dimensional system, that is the xy plane. Now, what is the range of this function? Range of f. Range of f means the collection of z values. And z is always lie in the real number lines, that is one dimensional. So range will be the collection of all such z values. Of course, these z will come from this rule 9 minus x square minus y square. But we should ensure that x is taking values in this interval minus infinity to infinity, y is taking values from minus infinity to infinity. So one thing is sure, z will be a real number. It's a one-dimensional case, right? Now let us see it here, right? We can write z as 9 minus x square plus y square. What will be the maximum value of z? Z will be maximum when the expression on the right hand side is maximum. And when will be the right hand side maximum? When this expression inside bracket x square plus y square is minimum. And what will be the minimum value of x square plus y square? It will be 0, right? Because sum of the square of two expression is always greater than equals to 0. So the minimum value of x square plus y square is 0. So the maximum value of z is equals to 9 minus 0, and that is equals to 9. Okay. What will be the minimum value of z? Z will be minimum when the expression on the right hand side is minimum. And when will be this expression on right hand side minimum? When x square plus y square is maximum. So x square plus y square the value maximum value of x square plus y square is tending towards infinity, is increasing and increasing and increasing without end. That is the meaning of infinity. So this is positive infinity, this is negative infinity, and some fixed number minus infinity, that is some fixed number minus numbers decreasing decreasing decreasing, it will be decreasing. So z minimum will be tending towards minus infinity. Okay, so the range of this function f is the interval minus infinity to 9, where the point 9 is included. So we have found the domain set as well as the range set of this given function of two variables. Now next we have to sketch the graph of this function. Now what is the definition of graph of a function? It's collection of all x, y, z numbers in the space such that the xy order pair belongs to the domain set and z is taking value from the range set. Now one way of doing it is through plot all these x, y, z points in space, and then their collection will give me the surface. But again, this is easier to say than done. But in this case, this function of two variables is a non-surface. So let us see how we plot it. Now we have the equation or the function as z equals to 9 minus x square minus y square, which we can write as 9 equals to 9 minus x square plus y square. We can rewrite it as z minus 9 is equals to minus x square plus y square. Let z minus 9 we transform it into capital Z. So this becomes z minus x square plus y square, where capital Z is equal to small z minus 9. Now in the previous video, we have explained that z equals to x square plus y square is an upward paraboloid. This was a problem we have solved in our previous video. The function of two variable was z equals to x square plus y square, and the diagram was upward paraboloid. So when the plus sign is here, it will be upward paraboloid. For negative sign, it will be downward paraboloid. So let us plot it. This is y-axis, z-axis, x-axis. Now z equal to x square plus y square will be a paraboloid in upward direction. So negative will be in downward direction, because whatever the value of x and y, x square plus y square will be always positive. So z will take negative values. So this capital Z will take negative values. So we will draw this paraboloid in downward direction. So first we are drawing the curve z equals to minus y square. Okay, it will be in yz plane. So this is paraboloid. So this is parabola in yz plane, right? And the second one, when we put y equals to 0 in xz plane, z equals to minus x square. So this will be in xz plane in downward direction. So this is xz plane, xz plane. And now we are, connecting all these 4 points. So this is our paraboloid in downward direction, right? And this is having infinite extent in negative z direction, but this is part of that paraboloid only. This is capital Z equals to minus x square plus y square. But our actual equation is z minus 9 equals to minus x square plus y square. So this minus means downwards, right? Now small z minus 9, it means we have to shift this graph by 9 unit in positive direction. If z minus 9 is there, it means the shift will be a positive one in z direction. So this vertex will be not here. This vertex will be 1 2 3 4 5 6 7. This vertex will be somewhere here. This point is 0 0 9. So this paraboloid, which is for z equals to minus x square plus y square, will shift 9 units in the z direction. So our diagram ultimately will be shifted paraboloid. So this will shift in the direction, this will shift in the 9 units above. Okay, so this is one part of the paraboloid. Another part of the paraboloid we are, and this will be our paraboloid. Z equals to 9 minus x square minus y square. On xy plane, z coordinate will be 0. So on xy plane, we will get a circle x square plus y square equals to 9. On xy plane, we will get a circle x square plus y square equals to 9. A circle, a part of this. So this coordinate is a radius of the circle. This is radius of the circle. So this point will be 0, 3, 0. So this paraboloid will cut y-axis at point 0, 3, 0 and x-axis at 3, 0, 0. So this is the sketch of the graph of the function given by fxy equals to 9 minus x square minus y square. This, which is nothing but a downward paraboloid shifted in the direction of z axis by 9 units. Thank you.